And welcome Math 212 students. We are back again today to look at section 7.4. So we're going to look at counting problems. We will look at permutations and combinations along with the multiplication principle. So let's look at the multiplication principle first. All right. So in order to get from my house to school, there are 3 different paths I can choose. I can choose that path, this path, or I can choose a roundabout kind of path. So 3 different paths. In order to get from school to the grocery store, there are 4 different paths. I could go this way, this way. Let's say there's one way that goes like this, or this roundabout path. So if there are 4 paths to get from school to the grocery store, I want to know how many different paths that could I take to go from one place to the other. So let's change my ink color here. Let's get like a nice orange. So I would count them. If I took this path, I could go that path, and then I could go this one. That's 1, 2, or I could go this way. That's 3. I could go 4. So there's 4 different paths total if I chose that one path. So let's add them up. 1, 2, 3. So there's 4 paths for the second selection, or if I chose this one, then I could choose one of those other 4 paths. So there is a total of 12 different paths that I could take from my house to the grocery store, given this scenario. We call this the multiplication principle. You'll see this used with a number of different outfits that somebody has. You'll see this with a number of different dinner selections, so that somebody might say you have 3 different shirts and you have 4 different pairs of pants. How many different outfits do you have if they all go together? And you just multiply the 3 times the 4, hence the multiplication principle. So that's the simplest counting technique. We're going to look at a couple of other techniques that aren't so simple, but multiplication principle is what everything boils down to. So we'll go on with a couple of other examples. All right, this is kind of an involved problem. So let's do this for 3 different people. So let's say we have 3 different people. And let's say we want them to stand in line for a picture, and we want to know how many different pictures we could have. So we could have Alice and Bubba and Carol stand, and that's one way to arrange them. We could have Alice, Carol, and Bubba. We could have Bubba, Alice, Carol. We have Bubba, Carol, Alice. We have Carol, Alice, Bubba, Carol, Bubba, Alice. So for 3 different people, there are 6 different arrangements of this picture. One way to do this is I like to make these little lines, and I go, how many different choices do I have for the first selection? And that I would say, oh, that's 3. And then how many different choices, once that person is chosen, how many different choices do I have for the next person? I would say 2. Then how many for the next person? And that would be 1. You multiply those together using the multiplication principle. This answer would be 6. There is a mathematical function called a factorial, and that is this exclamation point. And that exclamation point, you would read that as 3 factorial. And what that means is you start with this beginning number and you go down and you multiply. So if you were to punch this on your calculator, and you will find this button, if you're using the TI, you will find it in the math functions. You will need to find the math function, and then you scroll over to the probability tab at the top, and then if you look down, scroll down through the list, you will see that exclamation point or that factorial is listed there. So you would need to key into your calculator 3, hit math, scroll to probability, scroll down to factorial, press enter and then press enter again and you should get 6. Or so you could just do 3 times 2 times 1. That would get it too. So let's answer this question. They want to do 9 people. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9. And 9 choices for the first person, 7. This is, so I just keep on going down the line here. So the answer to this, if you're lining things up, and I don't care if it's people, books, whatever it is, if you're lining things up in order, it's going to be in this neighborhood. Now this is a big number. Let me punch this on my calculator. Okay, that is a big old whopping number there. So there are a lot of different arrangement of 9 items that you can put in a row. Another thing that you could do is you could look at the number of different, let's say, arrangements of license plates. So let's say we have 1, 2, 3. Let's say we have a 6 license plate, and these are going to be letters. These are going to be numbers, and let's say that we have no restrictions on anything. There are some license plates that they spell different things that are considered offensive, and those are restricted out of there. So we're not going to list those off. We're just going to look at what we could have if we had a license plate. So how many choices would I have for the first? Well, there are 26 letters, so there's 26 for the first. And if I can have repetition, meaning that I could have an A and then an A and then an A, then there'd be 26 for each one of these. How many different numbers are there? Would the digits go from 0 to 9? So there are 10 different digits. And you would multiply all of these out to find the total number of different license plates. So if I were to key this, 26 times 26 times 26 times 1, 2, it would be 1757600. That's a lot of different license plates with 3 letters and 3 numbers. And those are just typical types of questions in counting problems. Let's see what they have next. They define a factorial for us now that we've done one, and they say the factorial notation is that exclamation point and how we write it. And of course they're giving us the answer to the previous problem and telling us how they would do that. Technically it looks like this, but of course times 1 doesn't matter anyway. What do we have next? Let's see. Oh, they're just telling us that mathematicians put a 1 in there. This is the general formula. You start with your number there, and then you decrease it by 1. So like if this was a 9, you'd say the next one would be 9 minus 1 would be 8, 9 minus 2 is 7, and you carry on from there all the way till 1. Okay, so the harder thing that we're going to deal with has to do with what we call permutation or combination. Now I do have in your Blackboard course under Chapter 7, I have a little listing on how to enter these things in your calculator. There's a little video about permutations. You'll see the TI-83, 84 family of calculators and how to get a permutation or combination. Once again, it's the same thing as for the factorial, so I'll just list it. You find your math button, you scroll to probability, and you will find these buttons here. If you get, the first one is a random number, but the next one looks like this, and then the next one is NCR. So this is a permutation. This one is a combination. And then they have the factorial button. So permutation and combination. There's a lot to this. We're looking at this in one section of content, but there is an entire field of mathematics called combinatorics, and you can take an entire class on counting. So we're just touching on a few things of counting And it is fancy counting, but we're not going to really delve into it because there are textbooks written on this. We're just describing what it is and showing you a couple of different examples of what a permutation deals with and what a combination deals with. The main thing that you need to think about is, does order matter? If order does not matter, use a combination. If order does matter, use a permutation. That's how you'll know. So let's look at a couple of examples. Well, they're going to have me look at formulas first. You don't really need, you can use the formulas, but if you have the TI 8483 calculator, you can use that. And if you use your calculator and you have these buttons on your calculator, you actually won't need these formulas. But here they are. If you do need them, this is, if you don't have those buttons on your calculator and you can't get another one, then you would use these formulas. And you just follow along with them. So let's look at an example here. It says that we have an election and we are trying to elect a president and a treasurer. And how many different ways can we do this if we have a pool of 9 people? So we have 9 people, and we're going to pull 2 people out of there. Well, president and treasurer, does order matter? Will it matter to somebody if they are president versus treasurer? Yeah, that will matter. So because of that, because order will matter, since order matters, I'm going to use a permutation. Now, if you'll look at the formula, permutation when order matters means that my lists are much longer. Notice how with a combination, what happens is you essentially divide out all of the doubles. So combinations, this is a bigger list because order matters, and this is a smaller list because order doesn't matter. So I am going to do a permutation of 9, choose 2. And I will punch that on my calculator, and I will hit clear and on. Of course, it has to be on, and I'm going to key 9. Then I'm going to hit math, scroll to probability, scroll down to my permutation, enter a 2, and then hit enter, and I get there are 72 different ways to pull 2 people, assign them president and treasurer, and there's my list of 72 different ways to do that. Okay, this same group of 9 people now is going to elect 2 members to go to a national convention. So does order matter here? On this one, order does not matter, because it doesn't matter if they write your name on the list first or second. You're just one of the 2 members going. So this would be a combination of 9, choose 2 on a combination. So I'm going to hit 9 on my calculator, math, scroll to probability, scroll down to combination, 2, enter, and I get 36 different ways to pull 2 people out of a group of 9. Next, I'm going to consider a standard deck of playing cards, pick 2 cards. What's the probability of getting 2 queens? All right, let's look at this in 2 different ways. One way we're going to use combinations. The other way we're just going to look at it straight up. So I want the probability of a queen, and then another queen. And because this is an and probability, I'm going to be multiplying. The probability of the first queen is 4 out of 52 because there are 4 queens in a deck of 52 cards. Now, the probability that I get the next queen, I have to think about the fact that I'm holding one of those queens in my hand. So there's only 3 of them left out of 51. So if I were to reduce this fraction, I believe I get 3 goes into 51, 17 times, I think, and 4 goes into 52 13 times, and this would be 1 over, and if you multiply 13 times 17, I think you get 221. You could have also said and gotten this directly by saying, well, this is a combination. Order does not matter. So the probability of 2 queens is a combination. 4 queens, choose 2. And then the total different possibilities would be 52 cards, choose 2 of them. If you do this, then I think you get, let's see, let me compute that in my little calculator. 6 over 1, 3, 2, 6, which reduces down to 1 out of 2 to 1. So it's all a matter of which one makes the most amount of sense to you, and you can solve it by either method. So let's see what we have next. We're looking at lotteries. All right, this is our last example for this section and this chapter, actually. So we've got some lotteries. Okay. The winning lottery is selected by 10 ping pong balls, so 0 to 9, placed in a hopper. 1 is, okay. The process is repeated 3 times. What is the probability? Let's see how many. It has 1, 2, 3. I'm only doing 3 different numbers, in which players select 4 digits. So they select 4 digits. And so I draw my little blanks there to go, all right, there's 4 possibilities. So how many different ways can I do this? Winning number, 10 ping pong balls with a 0 through 9. 1 is selected, digit goes in that first place. So there were 10 choices because 0 through 9 are 10 of them. 10 choices for that one. So we put that ping pong ball back in. Okay. So he's back in there. So there are 10 choices for that second one. And then there are 10 choices for this one and 10 choices for this one. Okay. So it's 1, 2, 3, 4. So there are 10,000 different ways to do this. What's the probability? Although I don't think they use just 4 digits here. What's the probability of picking a winning number? That would be probability of the win, and you have to get it exactly like it needs to be. So that would be 1 out of 10,000, because I think it has to be in order. All right, although I think they require more than just 4 digits. But anyway, that is Chapter 7. And if you need any extra help, be sure and ask me for Collaborate. And if you need help on an individual question, be sure and send me an email and I'll work through a solution with you. All right, bye now.